Welcome to this explainer, Anatomy of Autonomy. Today we're diving deep under the digital hood to see exactly how experts view the incredibly complex robotics behind autonomous vehicles. We so often think of cars as just, well, mechanical machines, but the shift to autonomy has turned them into something else entirely. So let's dive into this and explore the true anatomy of autonomy.
Take me to the airport. Sounds pretty simple, right? To a passenger sitting in the back seat staring at an empty steering wheel that's just kind of turning itself, this command feels like pure, literal magic. But what we're going to look at today is the incredible engineering reality behind that magic, because that simple spoken command triggers one of the most complex computing and robotic processes in modern technology.
Before we put things in drive, let's run a quick diagnostic check on our agenda. We'll start with 1, the driverless illusion, move on to 2, how the car sees, 3, the artificial brain, 4, the expert decision loop, and finally, 5, the technology in action. Breaking it down this way is going to help us understand the mechanical and digital systems exactly the way the experts do.
All right, let's kick things off with our first section, the driverless illusion and looking beyond the magic. Imagine a car with absolutely no one behind the wheel, starting its journey simply because you told it to. It seems so effortless to us, but talk to an autonomous engineering expert and they'll tell you this isn't just a car anymore. It's a highly advanced robot. To simply exist and move on the roads safely, this robot is constantly pulling in a massive, honestly overwhelming amount of environmental data. The illusion is that the car is just driving. The reality is that it is calculating the absolute universe around it.
So how exactly does it calculate that universe? Let's move right into Section 2, how the car sees, focusing on the sensors.
To understand how this robot navigates, we first have to look at the hardware acting as its eyes. And it doesn't just have one set of eyes, it has multiple layers of perception. Cameras give the car its vision, using computer vision to spot colors and shapes. But cameras can't always see through heavy fog or accurately judge distance, so radar steps in to bounce radio waves and precisely measure the speed of other objects. Then LiDAR uses lasers to literally build a high-resolution, real-time 3D model of everything around the vehicle. Ultrasonic sensors step in to detect close-up obstacles, which is perfect for tight parking maneuvers. And finally, GPS paired with HD maps pinpoints the exact location and feeds the car critical, down-to-the-centimeter road details. To an expert, no single sensor is enough. It's this overlapping web of hardware that ensures the car never, ever has a blind spot.
Okay, now that we have all this chaotic, layered sensor data pouring in, we need a way to process it. That brings us to Section 3, the artificial brain and processing the world.
To make sense of all this noise, experts rely on a concept called sensor fusion. Imagine your cameras are seeing a red light, your radar senses a car braking ahead, and your LiDAR is detecting a cyclist creeping up on the right. Sensor fusion is the process where an onboard AI computer instantly weaves all of that incoming data together into one unified, crystal-clear reality. By utilizing computer vision and deep learning, the car's brain confidently identifies lanes, traffic lights, pedestrians, cyclists, you name it. It's essentially taking 100 different puzzle pieces and instantly snapping them together to see the big picture.
Pulling back the curtain reveals a massive, multidisciplinary tech stack running in the background. The car is relying on artificial intelligence, machine learning, and deep learning to constantly improve its understanding of the real world. It uses specialized operating systems like ROS and coding languages like C++ and Python to run these insanely complex algorithms. It relies on heavy GPU acceleration to crunch all that math in real time. And it even uses V2X, or vehicle-to-everything communication, which allows it to literally talk to traffic lights and other connected cars. All of this heavy lifting is dedicated to one ultimate expert goal: path planning. The experts truly view the car as a rolling supercomputer.
Once the AI completely grasps its environment, we enter the absolute most critical phase of autonomy. Section 4, the expert decision loop. Predict, plan, act.
Let's look at how this builds from perception right into action. The AI isn't just passively reacting to what is happening right now, it is actively anticipating the future. First, it has to predict what other road users might do. Will that pedestrian step off the curb? Will that guy cut into my lane? Once it makes those predictions, it must plan the absolute safest path forward. Only then does it make a concrete decision. Do I accelerate, brake, steer, or stop? This is the core loop we're talking about. Predict, plan, act. And here is the true marvel of autonomous engineering. This entire sequence happens many, many times every single second. That incredibly complex cycle we just talked about, sensing the world in 3D, fusing the data, predicting behavior, planning a path, and deciding to move, happens faster than you can blink. Because it's a machine, its reflexes are vastly faster and more consistent than human reflexes. It's constantly evaluating and reevaluating the safest course of action without ever getting distracted checking a text message or getting tired after a long day at work.
So what does this rolling supercomputer actually look like when it hits the streets? Let's check out Section 5, the technology in action, the drive.
This sequence perfectly captures the climax of our journey today. Bring in the eyes, the brain, and the reflexes together into a practical, real-world story. Watch how the complexity scales up here. Step 1. The car leaves a parking lot, perfectly centers itself in the lane, and uses computer vision to read a 60 km/h speed sign. Step 2. It detects a red light ahead and glides to a smooth stop. Step 3, and this is a big one, a child chases a ball into the street. The LiDAR and radar instantly detect that sudden obstacle. The AI predicts the child's path, and the car brakes rapidly, way faster than any human could react. Step 4, crisis averted. The drive calmly concludes as the car safely handles a tricky highway merge, dynamically reroutes around some unexpected road construction, and ultimately parks itself precisely between two painted lines. This step-by-step drive really shows exactly why all those layers of sensors and processing power are totally non-negotiable.
Ultimately, driverless cars don't simply drive. They continuously sense, understand, predict, decide, and act. This incredible fusion of AI, advanced robotics, and heavy-duty sensors is already fundamentally shaping the future of transportation. When you look at it through the eyes of an expert, it's not just a convenient ride. It is a marvel of human ingenuity taking the wheel. Which leaves us with one final thought to ponder. As this expert engineering continues to accelerate, how soon will it be before trusting a robotic brain with our daily commute feels just as completely ordinary as stepping into an elevator? Thank you so much for joining me on this explainer. I really hope you walk away with a much clearer view of the technology moving us forward.